So what I'll now go and do is get the declaration to match correctly, right? And if I do this, it is all okay, right? And this is the exact process that is followed by the compilers in order to generate the executable, okay? So now what I want to do is I want to focus on the output of this file, right? This is an object file. From the compiler you get a .o file, okay, and we want to understand what that whole thing is here, right? So now I am coming back to Godbolt, okay, so I am moving out of GCC, I am coming back to Godbolt. Every compiler will give you very similar, you know, it will process files in almost a very similar manner, okay. You will get mostly similar errors, some of them can slightly differ, but in general it's okay to switch between compilers seamlessly in order to understand all this. So what I have done now is, because this Godbolt is dealing with only one file, I am going to put the definition here, right, and I'll put everything in the same file, hash define okay, and int fn1 of int x comma int y, and I say return x into y into macro val, okay. So what I have now done, okay, hash define, I cannot do this, I have to say space 20, yeah. So what I have done now is I have put all of these things in a single file, okay, instead of putting them in different files. But I can do very similar things, okay. Now for example, I can do this, exactly the same thing that I did across files, I can do here also, right. What is it telling me? Too many arguments for function call, right, because my definition and declaration, basically my definition, declaration and the call, function call are different, right. Now if I make this int, right, then these two will match and you will be able to get the output appropriately, okay. Now what if I do this? Actually my function definition takes only one parameter, right, and I will say x into macro val, forget the y for now, so that I don't want a syntax error, because otherwise it will give me a compiler error on fn1 saying it doesn't know what y is, right. So these are very interesting things that can happen, okay. So for example, I am saying fn1 of int x, right, and then I am saying x into macro val, whatever the function definition is, whatever the function job is, I am putting it into that place there. But this function definition does not match with this function declaration. However, the function declaration is very much in line with the function call, okay. Now these are really funny cases. I can also do exactly the opposite. At least in that case the output seems reasonable, earlier case, right, when I did just int x, when I had just one function parameter, but I ended up calling it with two values, x comma y from main. At least this seems reasonable, it's giving me some reasonable answer. It seems to be doing 820 into 20 into 20, right, because macro val is also 20, it seems to be giving me 8000 as the answer, which is at least reasonably correct. Now I will do something else here, right. I am going to now change the function declaration to just this thing, but I will match it, because if I do this I will get a linker error, I mean compiler error. Now if I do this, what is going to happen? I will get a perfectly consistent thing, because for fn1 declaration says fn1 takes one parameter, fn1 is being called with only one parameter x, right? And internally, let's say instead of x into y, I'll do this now. Okay, I'm going to restore it to this. So the function definition fn1 takes two parameters x and y, and I'm returning x into y into macro val, but the function fn1 is being called very specifically with just one parameter x, which matches the definition fn1 perfectly. Okay, these are very funny cases. Sometimes you could get a linker error. It depends on your compiler's configuration. For example, what will happen is, if the function declaration and the function call are consistent with each other, right? For example, like here, file1.h, right, file1.h and file2.c are consistent with each other. I am going to call this with only one x value, right? These two are perfectly consistent with each other, right? And then when I do GCC minus c file2.c, this will compile perfectly because the function call and the function declaration match perfectly, right? At the point of compilation, this compiler GCC does not even care for or does not even know about the existence of the actual function fn1. It does not know how that function looks, okay? And that is why when you try to do the compilation of file2.c, it compiles correctly and generates an object code, but when you try to link it, right, and try to run the linker on the object code file2.o, it will tell you that it does not know what fn1 is, okay? Now likewise, if this if I now try to do GCC minus c file1.c, right? Yeah, now this is interesting because here again the declaration and definition are off, okay? But let's again look at this a little closely. File1.c. Why is this a problem? Why am I getting a compiler error? It's basically saying that in file1.h you have defined it as single parameter. fn1 takes single parameters, one integer, but here you are defining it like this. So technically if I delete this, right, actually I don't need the declaration here because the definition itself is in this file, right? So if I delete that and then do GCC minus this, of course this macro val will cause a problem, right? That's the reason I needed it, okay? So let us see how we can, suppose I'll say I'll replace this myself. I don't want to deal with that confusion, okay? Now GCC minus c file1.c compiles perfectly, right? Why? Because this function, when it was compiled by the compiler GCC, it does not even know that there is a declaration which does not match this definition, okay? And therefore this thing can go through. Now when I do file1.o, file2.o, you are getting a reasonable output, okay? So if you do a.out, you will get some junk value here. You will not get the right answer because you have assumed that you are, the function when it was called, is being passed only one parameter, but when the function is being used, it actually assumes there are two parameters passed to it. So we'll come to these discrepancies later, but technically at this point, you could see a linker error as well, depending on the configuration of your compiler. Okay, and basically what we are saying here, right, is exactly this guy, right? And the behavior of the compiler, look, for example, in this case, we got some 12,000, right? But this compiler is giving us some random value. Okay, so these are weird behaviors, but later you will see that this is not all that weird, it is very deterministic. Okay, that's the aim of our thing. Now, cutting this long story short, right, we basically had multiple things that we were looking at. So, if the function call and the function declaration match, you will not get a compiler error. You could get a linker error if that function declaration and function actual definition don't match, or the compiler might let it go also. Okay, and you will see later in this next week why it is okay to let that go. Okay, so we'll come to that a little later. So therefore, what I want to highlight here is the compiler is doing a very specific job, right? So you give it a C file, okay? Technically, I don't even need to know what this is. Technically, I don't need to know what this is. Okay, I can just remove that function definition, but of course, you will get a linker error because it has no idea what that fn1 is. However, you see that it has been able to give you and compile fn, the file that it gave it exactly like this. That means what you see here is the contents of the object file that matches file2.c. Okay, so the compiler therefore is only looking for an internally consistent code, C code, right? For example, it looks at fn1 and it says, okay, there is a function called to fn1. I just need to know how this function should actually look. Okay, so that's why if you remove this function declaration above, right, either through a header file or by directly putting it there, you will get a compiler error here, right? Or it has to implicitly assume that there is a function definition which matches this fn1. Okay, that's how it will work. So let me see what that is. If it, so this is what we saw, that implicit thing even in GCC, right? So what is the job of the compiler? The job of the compiler is to take code that is available in that particular file and generate the assembly equivalent of the for that particular processor, so that the object code, when later assembled together with other object codes, can give you an executable. Okay, so in some sense, this call to fn1 should get compiled to an appropriate function call even without knowing what the actual definition of fn1 is. The compiler needs this particular declaration here to simply guarantee the compiler that, look, there is a function like this whose declaration is given here. You just check the declaration matches all the function calls with this. However, the actual definition of the function will be provided to the linker at a later point. It's the linker that actually puts all of these things together and eventually gives you an executable, right? So the whole point of our exercise of taking a C code and compiling it, or understanding the process of compilation to the assembly code, is going to be one of looking at that particular file. We should be able to translate it to the assembly call appropriately without worrying about what the actual definition is, Or for example, if I'm now looking at compiling this particular file, file2.c, right, GCC file1.c, I'm sorry, right, sorry, minus c, yeah. So what is this call? It's saying fn1 int x comma int y, it's doing return x into y into 20, right? It does not even know how and where this function fn1 will be called from, from wherever. It needs, therefore the compiler needs to compile the code in a way that this function 1 can be called from anywhere. You enter, and when you exit, you should go back to that place correctly without messing up any execution sequence, right? That is the job of the compiler. So the compiler, of course, again, there is an obvious job of the compiler, which is to take your C code and generate the appropriate assembly so that you can implement the task given here. Like you have x into y into 20 here, I need to do some multiplication, so I'll use a mul instruction or something like that. The compiler has to do. But again, that is the obvious part of the compiler, right? So we are going to take a C code and translate it to its assembly equivalent without worrying about where and how this function will get called or will get used at any point in time. The compilation process or the assembly code that you generate must be consistent and correct irrespective of how and where this function gets called, right? That is the aim. So on a finishing note, let me just sort of wind up this discussion by going back to this, it happened by chance here. I'll do GCC file1.c. Okay. What is it saying? It is saying it is unable to generate an executable. Okay. So what I'll do, I'll again remove a.out. Oh, that is already gone. Okay. File star.o, I'll remove the object files and I'll do this GCC file1.c, right? It is giving some error, undeclared reference to main, LD returned 1, right? Basically it is saying that the linker has not found main, okay, whereas if I do minus c, it seems to compile correctly. It is generating the file1.o object file. So what this basically means is that when the file1 is compiled, that is using the minus c option, when I say compiled, I mean actually only doing compilation after pre-processing, right? It does not care for whether there is a main or not, okay? Whether main or not, whether main exists or not is not the worry about the compiler, it is the worry of the linker, because the linker is what is going to put all the functions together, right? Because each of these functions files would have got compiled separately. The linker is going to put them all together, and then the linker is going to definitely look for a main. So what is a main? Basically main is the entry point of your program, okay? So there is a, int main, okay, and then you write some arbitrary C code in there, okay. So when you do a.out, what does it mean? It means that, so when I do a.out here, okay, I'll do the GCC file1.c, right? I've been able to generate the a.out, right? So when I do a.out, what the operating system does is it looks for where the main is in this particular executable, and it will hand over control to main, okay? So the operating system itself is a program that is running on your computer, Remember, if you don't have multi-threading and multi-processors and stuff like that, at a time only one program can run on that processor, on the microprocessor. Normally it's the operating system that's always running. It is running something, right? It is trying to run something. So in the good old days, when you had your entire OS sitting as a terminal like this, the operating system would launch this terminal and would be awaiting an input from you, from the user, like this. Okay, it is just waiting for that. Then when I say ./a.out, it will execute that particular program. Now what does execution of that program mean? It means the operating system hands over control to the entry point of main. That is, whatever code appears here, right? You can have int x equal to 0 something, and then you do a lot of it, right? The entry point will be here, and it executes whatever is in main, and then it exits, handing over control back to the operating system, right? So the main is the duration when the execution is in main is the duration for which your program is actually running in the microprocessor. And if you don't have multi-threading, nothing, right? It's just a simple serial thing that's happening. Then what's going to happen? The operating system awaits your input. You do a.out. It hands over control to main. It executes. Then it exits and comes back to the operating system, where it continues to wait for another input from you, right? Of course, nowadays with all this GUI and other things, the operating system is always doing something where it is doing multi-threading and stuff like that, where one program is run, then it is coming back and refreshing the screen, it is scanning for so many other things, it is doing something on the GUI, 100 other things are happening, but these are all nice illusions for you. Why? Because the speed at which the processor works, right, is very, very fast. We are talking of tens of nanoseconds, right, or maybe hundreds of nanoseconds, which is much faster than what the human can perceive. So we don't see the context switching happening from the operating system to GUI refresh to running your program. Everything looks like it's happening in parallel, right? But actually only one of these things is executing on the processor at a given time, assuming it's a single core processor with only one processor available for you, right? So the linker looks for main and then ensures main is there, and if main is not there, it will not compile, it cannot make an executable, because the executable needs a main why? Because the operating system is going to look for that. Therefore, if the main is not there, the linker will throw an error saying main unavailable, and therefore it cannot link and create the executable for you, right? So the job of our compiler, so we are now going to play the role of a compiler over the next week. Our job is not to find syntax errors. Assume all syntax errors are fixed, it's all very clean. We are just going to look at a C code and translate it to its assembly equivalent, so that it is going to be consistent from wherever it is called, and program execution can be handed over back to whoever called it without any conflict.